small shop owner has bought in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Swaras. We are top on the Everest. Congratulations.
I want to be a leader.
Hi friends, how are you all? Had your lunch, friends? I think you all are eagerly waiting for my class, right? Yes, let us start our class now. I am N.Sucharitha from Center of Excellence studying Senior MPC, and today I am dealing the subject chemistry. In that, my topic is optical isomerism, especially in coordination compounds. Friends, I think everyone is aware of some simple things in coordination chemistry, right? Even though, let us go back to basics and recall some of the simple things in coordination chemistry. Friends, the first simple thing is that simple salt. Simple salt is a compound which is electrically neutral and is formed by the electrostatic forces of attraction between anions and cations. Friends, let us see an example here. Here is a simple salt. A simple salt is a compound which is electrically neutral and is formed by the electrostatic force of attraction between anions and cations. Here are some of the examples. Those are sodium chloride, magnesium chloride, aluminum chloride, etc. Friends, we all know that sodium chloride is a simple salt which we use daily in our life, and if we observe in that sodium chloride, here we can see the simple salt sodium chloride contains Na plus and Cl minus simple ions. Such salt containing simple ions is nothing but a simple salt. Friends, now let us go for addition compound. An addition compound is defined as when two or more compounds or two compounds when they are mixed in their stoichiometric proportions and when they are heated up to evaporation, they gives rise to a new crystalline compound. That is nothing but addition compound. Friends, we can see here an example. Addition compound. When solutions of two or more salts are mixed in their stoichiometric proportions and then evaporated, crystals of new compounds separate out. Friends, we can see here two examples. One is potash alum and the second one is potassium ferrocyanide. Friends, can you observe here in the second one we are seeing a complex, but whereas in the first one there is no complex. By this we can divide these addition compounds into two types. They are addition compounds are divided into two types. They are double salts and coordination compounds. Friends, let us now discuss about double salt. A double salt is a compound when two compounds are mixed in their stoichiometric proportions and when they are heated up to evaporation, they gives rise to a crystalline compound, nothing but a double salt. And here the double salt, we have one example, that is potassium chloride, magnesium chloride. When treated with water, it gives K plus, Mg2 plus and Cl minus ions. Here carnallite is formed by mixing KCl, MgCl2, 6H2O, or in aqueous solution they gives rise to K plus, Mg plus 2 and Cl minus ions. Let us see that reaction here. Friends, Carnallite formula is nothing but KCl, MgCl2, 6H2O. It is nothing but carnallite, and this carnallite is formed by mixing potassium chloride and magnesium chloride in their stoichiometric proportions, and we can observe that in potassium chloride we can find K plus and Cl minus, whereas in magnesium chloride Mg plus 2 and Cl minus ions, and when they are heated up to evaporation they gives rise to a crystalline compound nothing but carnallite. And if we want to observe here one thing friends, that is this carnallite when treated with water or this carnallite when treated in aqueous solution, it again gives rise to the same ions, those are K plus, Mg plus 2 and Cl minus. By this we can conclude that the compound which does not lose the properties of its constituent ions is nothing but a double salt. Friends, now here we can see the definition of the double salt is when the two compounds are mixed in their stoichiometric proportions, and when they are heated up to evaporations a crystalline compound is formed, and the physical and chemical properties of double salts are same as those of the constituent ions. Here is an example, that is carnallite, and when it is treated with water it again gave the same ions, they are K plus, Mg plus 2, Cl minus ions. Friends, now let us discuss about coordination compound. A coordination compound is also an addition compound, and it is also formed by mixing two compounds in their stoichiometric proportions, and when they are heated up to evaporation they too give rise to a crystalline compound nothing but a coordination compound. The difference is very little difference, that is we can see here. Friends, let us see an example, that is potassium hexacyanoferrate 3, which is formed by, this is a coordination compound, and this is formed by mixing potassium cyanide and ferrous cyanide in their stoichiometric proportions. Here potassium cyanide and ferrous cyanide are mixed in their stoichiometric proportions, and when they are heated up to evaporation they gives rise to a crystalline compound nothing but potassium hexacyanoferrate 3. And if we observe here, in potassium cyanide we can find K plus and Cn minus ions, and whereas in ferrous cyanide we can find Fe plus 2 and 2 Cn minus ions. And when this compound is treated with water or this compound is treated in aqueous solution, it does not give its constituent ions, rather it gives rise to new ions. They are nothing but 4K plus and Fe Cn taken 6 complex minus ions. Here we can observe clearly that before they are combining they have different ions, and after the compound is formed and it gives rise to different ions. By this we can conclude that the compound which loses the properties of its constituent ions is nothing but a coordination compound. Friends, I think now you all are clear about double salt and addition coordination compound. Let us see the coordination compound here. A coordination compound, the example of the coordination compound is potassium hexacyanoferrate 3, and these are also called as addition compounds. They exist in crystalline state when dissolved in water or in a suitable solvent does not give its constituent ions. Friends, here we want to observe one thing, that all the compounds does not ionize only in water. Some has different properties. They ionize in some suitable solvents. See here friends, here when this potassium cyanide and ferrous cyanide are before mixing they formed K plus, Fe plus 2 and Cn minus ions, but after they have formed as a compound they gave rise to some new ions here. By this we can conclude that the compound which can loses the properties of its constituent ions is nothing but a coordination compound or a complex compound. Let us know how many types of coordination compounds are there here. There are 3 types of coordination compounds, friends. They are, see friends, one is anionic compound and the second one is cationic compound and the third one is neutral compound. Here how we are differentiating those compounds, let us see. Here in this anionic compound, when this potassium hexacyanoferrate is mixed with water, it gives rise to 4K plus and FeCN taken twice minus 4 ions. Here we want to observe one thing, friends. Here in this complex, in this compound, this complex carries negative sign. In this compound we can observe that this complex carried negative sign. So this complex is called as anionic complex, whereas here the complex carried positive sign. We can observe here clearly, friends, a complex carried positive sign. So this compound is called as cationic compound, whereas in neutral compound, when this compound is treated with water, it does not ionize, friends, it remains same. So this compound is called as neutral compound which has no charge on it. I think you all are clear about now anionic, cationic and neutral complexes. Now let us see what a coordination compound contains. Let us see, friends, here a coordination compound. Here is a good example of coordination compound, that is nothing but hexamine cobalt 3 chloride. Here the example is hexamine cobalt 3 chloride. Here in this we can observe a complex and the ions inside the complex and outside the complex. Then what are these ions are called, friends? Let us know. Here the CO, cobalt, is called as central metal atom and NH3 is called as ligand and Cl minus is called as counter ion and CONH3 taken 6 which is in the bracket is called as coordination pair. Now let us see clearly them. Here we can observe a square brackets in this compound. Here is a square bracket and this square bracket is nothing but a coordination pair, and inside the coordination pair we can find a central metal atom and the ligands. Then in this two, which is central metal atom and which is ligand, we gets confused. Now let us see. Here the very first atom in the coordination pair is nothing but central metal atom. Here the very first atom is nothing but cobalt. So cobalt is a central metal atom here, and the ligands are followed by this central metal atom. Here the ligands are followed by this central metal atom. Therefore NH3 is ligand here, and there are some of the ions which are outside the complex. That ions are called as counter ions, friends. Here, and the number which is prefixed to this ligand or the number which is bonded to the central metal atom, that number is called as coordination number of that complex. Here we can see a diagram, friend. In that we can observe that this total picture is of a coordination compound, and here the central metal atom and the 6 ligands are bonded to this central metal atom. The 6 ligands are of amines and the central metal atom is cobalt, and this square sphere or this square bracket is called as coordination pair, and the ions which are outside the coordination pair are called as counter ions. I think we are all clear about a coordination compound. Now let us have a look on isomerism, friends. Isomerism is nothing but when the two compounds have same molecular formula but they differs in their physical and chemical properties on account of their structures and spatial arrangements of atoms or groups. We all know that organic compounds fairly exhibits isomerism. Like organic compounds, inorganic compounds also exhibits isomerism. Let us see here friends. Like organic compounds, inorganic compounds also exhibits isomerism. In that inorganic compounds, coordination compounds also exhibits isomerism. Let us see what is isomerism. Isomerism is defined as the compounds which have same molecular formula but they differs in their physical and chemical properties on account of their structures and spatial arrangements of atoms or groups around the central metal atom. And this isomerism is a Greek word in which iso means same and meros means parts. Finally, isomerism means same parts. Let us see friends. Here, isomerism is coined from words iso and meros, in which iso means same and meros means parts. Here, isomers have same molecular formula but they differ in their properties, that are physical and chemical properties. Friends, in this coordination compounds, the isomerism is again divided into two types. One is structural isomerism and the second one is stereoisomerism. What is structural isomerism friends? Structural isomers are the isomers which differs in their structures, and stereoisomers are the isomers which differs in their spatial arrangements of atoms or groups around the central metal atom. Now let us see what are structural isomers. Here, isomers of complex compounds, first one is structural isomers. These are the isomers or molecules that have the same number and type of atoms but they attached in a different order. Friends, here is a very best example. Here, these two compounds have same molecular formula. We can observe the chromium is 1 and the water molecules are 6. Here also 6 and here also 6. 5 are inside and 1 is outside, and 3 chlorine atoms. And if we observe friends, here these two compounds have same molecular formula but the arrangement of the atom or the structures of the atoms is different. Due to the difference, see friends, they isolated in different colors. By this we can say the structural isomers are molecules that have the same number and type of atoms but they are attached in a different order. Now let us see what are stereoisomers. Here friends, stereoisomers are molecules that have same number and type of atoms and that are attached in the same order but the atoms or group of atoms point in a different spatial directions. Here we can observe friend, platinum is a central metal atom in these two compounds, and here the green molecules indicates chlorine and the blue molecules and the white molecules totally indicates ammonia. Here we can observe that in these two compounds the molecular formula of these two compounds is same but the spatial arrangements of the ligands around the central metal atom is different, right friends? Yes, the spatial arrangements of the central ligands around the central metal atom is different. This difference is nothing but stereoisomerism. And friends, this structural and stereoisomers are again subdivided. How? Here isomerism is divided into two types. One is structural and the second one is stereo. And let us see how the structural and stereoisomers are again further divided. Let us see friends. Here the isomerism. Isomerism is divided into structural isomerism and stereoisomerism, and this structural isomerism is again further divided into four types. One is ionization isomerism, the second one is coordination isomerism, the third one is linkage isomerism, and the fourth one is hydrate isomerism. And here stereoisomerism is also divided into two types. One is geometrical isomerism and the second one is optical isomerism. Now, let us have a look on these types of structural isomerism. Let us see friends, types of structural isomerism. There are 4 types. One is ionization, the second one is hydrate, third one is linkage, and the fourth one is coordination isomerism. Now friends, let us have a look on ionization isomerism. Here in this isomerism, the two compounds have same molecular formula, but friends, they differ in their ionizable ions. Such isomers are called as ionization isomers, and the phenomenon is ionization isomerism. Let us see friends. Here the ionization isomers, this type of isomerism arises due to the difference in ionizable ion. Here we can see these two compounds have same molecular formula. Observe friends, 1 cobalt and 1 cobalt, 5 ammonia and 5 ammonia. Here 1 bromine and 1 bromine, 1 sulfate ion and 1 sulfate ion. But this existed in two compounds and the molecular formula of these two compounds is same, but when they are ionized, they gave rise to two different ions, because here we want to observe one thing, that the sulfate ion is outside the complex, whereas here the sulfate ion is inside the complex. Due to this small difference, they gave rise to ionizable ions. Here we can see clearly. This type of isomerism arises when there is the difference in ionizable ions, and such isomerism is called as ionization isomerism. Friends, now let us see what is hydrate isomerism. Hydrate isomerism arises when the ligand water molecules takes replacement with the water molecules outside the coordination sphere. Understood friends? The hydration isomerism arises when the ligand water molecules replacement takes place with the water molecules which are outside the coordination sphere. Let us see friends. Hydrate isomerism. Isomers of crystalline complexes that differ in whether water is present inside or outside of the coordination sphere. See friends, there are 3 examples for us. In these 3 examples, if we observe, the molecular formula is same, but whereas here the total water molecules are acting as ligands, so the color exhibited is violet. And here if we observe, 5 water molecules are acting as ligands, whereas 1 water molecule is an ion, and here we can observe that chlorines are 3 outside, here 1 is inside and 2 are outside. Here also the same thing, 4 water molecules are inside the coordination sphere and 2 water molecules are outside the coordination sphere. Due to the small difference of replacement of water molecules of ligands which takes place with the ions, that gives rise to hydration isomerism, and we can observe here clearly friends, the replacement of water molecules gave different colors here. The first one gave violet color, and the second one gave blue green color, and the third one gave dark green color. Now let us see what is linkage isomerism friends. Linkage isomerism is nothing but when a compound containing an ambident ligand. What is ambident ligand friends? An ambident ligand is a monodentate ligand which has 2 different donor atoms. An ambident ligand is a monodentate ligand which has 2 different donor atoms. Friends, here we can see clearly linkage isomerism. This type of isomerism arises in the coordination compounds containing ambident ligands. We already discussed what is ambident ligand. It is a monodentate ligand which has 2 different donor atoms. See friends, here these 2 compounds have same molecular formula, but here the ligand is NO2 and here the ligand is ONO. Here we can observe that nitrogen bond with central metal atom, that is cobalt, whereas here oxygen bond with central metal atom, that is cobalt. In these 2 structures we can observe clearly friends, here the blue molecules represents nitrogen, and the red molecules represents oxygen. Here also the same thing, blue represents nitrogen and red represents oxygen. Here the blue, that is nitrogen, is bonded with central metal atom, and here oxygen is bonded with central metal atom. Due to this small difference in linkage, the linkage isomerism arises. Linkage isomerism arises when in the coordination compounds containing ambident ligands. Now let us have a look on coordination isomerism, friends. Coordination isomerism have two spheres, one is anionic sphere and the another is cationic sphere. In this, anionic sphere and cationic sphere contains, and the arrangement or the replacement of ligands takes place. In this PPT we can see clearly, friends. Coordination isomerism. Here are the examples. We can see here the two compounds have same molecular formula and they have the replacement of ligands. Here observe, friends, here cobalt is bonded with amines and chromium is bonded with cyanides, whereas here chromium is bonded with amines and cobalt is bonded with cyanides. Due to the replacement of ligands or arrangement of ligands, this coordination isomerism arises, and this coordination isomerism is shown by such compounds which contain both cationic and anionic spheres and the exchangement of ligands takes place. I think you all are clear about structural isomerism. Once again, friends, structural isomers differs in their structures, and this structural isomerism is again divided into four types. One is coordination isomerism, the second one is hydration isomerism, third one is ionization isomerism, and the fourth one is linkage isomerism. We all discussed about those four isomerism. Now let us have a main look on stereoisomerism today. Here we already discussed that stereoisomerism is divided into two types. One is geometrical isomerism and the other is optical isomerism. Here, friends, geometrical isomerism arises when two compounds have same molecular formula but they differ in their the ligands which are bounded to the central metal atom. Friends, here we can see an example, friends, for geometrical isomerism. Here are the central metal atoms, but the ligands are arranged in different positions to this central metal atoms. By this we can say that the geometrical isomers are the isomers which have difference in their spatial arrangements, and this geometrical isomerism is also called as cis-trans isomerism. In cis isomers we can observe the identical molecules or identical ligands are placed adjacent to each other, whereas in trans isomers the identical molecules are opposite to each other. Here we can see clearly, friends, here the two identical molecules are adjacent to each other, so this is called as cis isomer, and here the two identical ligands are opposite to each other, so this is called as trans isomer. And these isomers differ in the geometric arrangements of the ligands around the central metal atom. Friends, now mainly today we should focus on optical isomerism. Optical isomers are the isomers which differs in their rotation of plane of polarized light, and coordination compounds can rotate the plane of polarized light. I think you all had a doubt that what is plane of polarized light and how this coordination compounds can rotate this plane of polarized light, right? Now let us discuss about that. This plane of polarized light is nothing but which came from normal light. Friends, we all know normal light, right? For example, sun, lamp, light, bulb, etc. So first consider a normal light.